Welcome, everybody. We're going to be working on Unit 4 tonight. We're going to start by looking at some concepts. The main point of tonight's session is to work on the key commands of insert, update, and delete. Thus far, as we've been working with databases, we've been working with databases that have been pre-structured for us, and that already include information. What we're going to do in terms of at least an exercise tonight is learn that we can build something from scratch, how to do that, and then how to put information into the database. And we're going to start with a couple of really powerful commands here, the create database and create table, because those are necessary to know. We're not going to go really deep on these tonight, but I just want to show you that it's possible to do. We'll talk briefly about data types, because when you set up a table and you create columns, you have to know what kind of data is going into those columns. So that's important. And once again, we'll revisit that topic many times throughout the course, and we'll have a deeper dive on it in one of the units coming up. And then we'll look at the commands of insert, update, and delete, which are really the primary reasons why we're here tonight. Insert allows you to add a record to a table. Update allows you to change a record in a table, and delete allows you to remove it. Right. So that's kind of the brief overview. Let's jump over to W3 Schools. And you know what? I did this last time too. I'm going to do this over in the Brave browser today, so that we can avoid as many ads as possible on the screen as I'm recording. This product automatically blocks most of that stuff. All right. So when you're working with MySQL, there is a way via SQL code to actually create a database out of thin air, so to speak. And you can see the command. It's very, very simple. You say create database. Those are both keywords. And then give it a name and a semicolon. And it would create it. So that's a very simple one. Notice that there's a little tip that they give here, and this is a pretty important one. If you're working on a database system where you are an administrator, or let's say a higher level user, you can do this. But it's not unusual if you are working, especially on somebody else's database system or at work or something like that, they might not give you that capability. You might be able to retrieve information from the database, but you cannot create anything. You cannot alter anything. You might not even be able to delete anything. We don't know. Usually that's done at a higher level. But all of us, when we installed MySQL Workbench and MySQL on our machines here locally, created our own root accounts, and that's the master administrator account. So you do have that capability. Later on in the course, we will do a little exercise where we create alternate users for a database with limited capabilities, and then have them try actions just to see what happens. And you'll get a much clearer picture of that level of control. But basically, there's different types of users with different types of capabilities. You must be an admin or above to be able to create a database. So that's the general command on that one. That's actually a pretty simple one. Now I am going to jump back to Chrome here just to start grabbing the links. And yeah, this is kind of a silly way to do it, I suppose. I should have had it all queued up in Brave, would have been, or I guess I could just look for it. Let's try that one more time. There we go. Next, once you have a database built, keep in mind, when you build a database, it doesn't look like anything. It's not a table. It's just a construct that's ready to hold tables, right? So if you want to actually build a table, there's a separate command for creating tables, which is, of course, create table. And then you would, the general syntax here is to give the table a name, however you decide to name it. And then I want you to notice inside of parentheses, you start indicating the name of each column and what kind of data it is. Is it characters? Is it numbers? Is it a date? Is it something else? Yeah, there's other stuff you can put in too. But generally, most information tends to fall into those categories, right? Words and characters, numbers, and dates. That's what we tend to use most often. So column name, data type. Another piece of information that you might throw in, by the way, is the information that designates that something is a primary key or that that value in the table is unique. Usually we put that on an ID field. So here's an example of them creating a table from scratch with 5 columns, right? The table is going to be called persons. We're going to have an ID. Okay, that's going to be an integer. Okay, so that's just a counting number. And we'll talk about these data types in just a little bit here. Now we separate each column and data type by a comma, right? So you could string them across the screen, but it's easier to go down. And then we'll put in last name, first name, address, and city. And then for all of these, because these are characters, we use a special field, very common one to use for characters, by the way, called varchar. That's how I say it, right? And really what it means is various characters. Yeah, you want to say that, go for it. But I think pretty much everybody in industry says varchar, really kind of awkward. And then in parentheses, how many characters are allowed in that field? I will tell you, when I saw this on W3 Schools, I was like, gasp. I'm like, what database person would allow 255 characters for a last name? Right. And this is to show you that we've kind of jumped into a more modern era now where people don't think about memory management so much. But in the old days of doing database, you'd probably sit around a boardroom and have like a big debate among computer scientists about how many characters are wise to use and how much data it occupies and how many last names on a percentage fit within X amount of characters. And personally, I would probably cap a last name at something like 25 to 30 letters. That's what I would do, right? Because even if somebody had a hyphenated last name, it probably will fit, right? But flip side, right? If your database isn't that large, you don't care so much about storage or efficiency, you can make it really kind of as large as you want. Usually you would plan this, but I'll give you an example. If I had a field here for zip code, how many characters would be wise for a zip code? Yeah, most people will say 5, right? All right. Anybody that's worked for the post office or delivered a package knows that there's the 5-digit zip code, then they have a dash and 4 more digits, right? And okay, throw in Canada, or some weird like US territory where they have like these, they're not even numbers, they're not really, well, they're still called zip codes, but they're not numbers necessarily, right? So a lot of people think, okay, a zip code should be a number because they're numbers, but the combination of a 5-digit zip code, a dash, and 4 more digits, or switch over to Canada or like a British one or something weird like that where they use letters and numbers. So I would make it characters and I would make it at least 10 characters long, if not longer, right, for zip code. Just to give you ideas about like how this stuff works. And I wouldn't make it longer than that. I don't think that would be necessary. I think that is wasteful of computing resources. All right, so that's the basic approach of how to create the table. After you run it, of course, and you look at your table, it will be created, but it will be empty. It will contain no data, but it will have the columns. And if I was like in MySQL Workbench and I looked at the table, like I clicked on one, I could see the column names and notice, the data types are declared here, right? And so whenever you're looking at this schema thing and that little information window in the bottom left, it's always pointing out the column names, the data type, the size of the columns. And like here, like for example, as they're like putting in information, you notice like they have, I think, more reasonable limits on their data here. All right. So that's basically how you create a table. There are ways, by the way, and your brain might already start going here, that if you run a query, that you can take the output of the query and convert it into a new table. right? And this is what they're trying to display here. We will once again go deeper on this later in the course. But in other words, you would just basically issue that command, use the as keyword, and then just write your query. And whatever the output of that is, would create a permanent table structure in your database. Okay, permanent is it's maybe not the best word, but it creates a table structure in your database that you can use for other things. Now, that might sound like a little weird to do, but there are uses for that, but and that is absolutely possible. Um, and they have a little example of it here. All right, let's move on to the next topic, and I'm going to see if I can be a little more clever about it this time. We're looking for data types, so I'm just going to do that right inside of Brave here. So somewhere here, we start talking about data types. Now, the data types become relevant because when we start to create those columns, we have to know what kind of information is going into our database. Like if we're working with a programming language, like is a number going in here? Is a word going in here? What is going into this thing? This usually in a programming language, think of it as a variable. And unfortunately, a lot of my, especially my data on AI students, we learn Python where there's no strong data typing. When we declare a variable in Python, we don't say it's characters. One moment we can put characters in it. The next moment we can put numbers in it. The next moment I can store video in it. You know, it doesn't really matter in Python. But in a database, it matters to the extreme. Because if I set up a numeric field and I try putting characters in it, it's just not going to work. And most programming languages, and I'll use traditional ones like Java or C Sharp, those are like the big compiled languages these days, do have strict data typing. So when I declare a variable, I have to declare its type, and it can only hold that type. Right. One of the reasons we write computer applications that have strongly typed data is because many of those applications feed or read data from a database, and a database is super finicky. So if you can put a front end on it with software to make sure the data type that you're working with is correct going in, then your database doesn't crash. See, and this, you know, this gets into like programming theory and stuff, obviously, but there is an importance, right? So like if you guys are just Python programmers and don't know other languages where Python is not strongly typed, and now we're working with a database that is, you really got to think about the stuff that gets stored inside there. If you're expecting words, use some sort of character type. If you're expecting numbers, you use some sort of numeric type, right? And there's more types. Now, when we're building our columns, I'm just going to kind of go through this list because it's kind of extensive. I want to show you all the different data types that exist. Now, once again, we're going to do a deeper dive on this later in the course, so I'm not really going to go through each one of these, but I'm going to show you some of the ones that we're going to use. Really common one to use is varchar, right? For characters. Notice size is a placeholder, right? And you can make a column in a table in MySQL to contain up to 65,535 characters if you wish. So that's the max size. I don't know why you would set it to 0, but I have seen people do that for weird reasons. Normally, you want to declare what you think is reasonable. If you don't declare it, it is possible to not declare it. I think it auto defaults. Now, for whatever reason, most people go to varchar when they're doing text. But I think it is pretty notable to say that, like in the old days, we typically use just this one, the regular character one, to hold most text because we usually didn't go beyond 255. If you think about it, if I do a varchar, I could, for example, have a website that has a comment form where somebody wrote like 10 paragraphs, and it would probably fit in there if I made it 65,000. Yeah, so that's the kind of, you know, sizes we're dealing with. But I would implore you, think about the information that's being entered. How much space do you need at a maximum? how much space do you need on an average, and figure out a number that works. Understand that if you put in information that's bigger than the container, it will not all fit, right? Have you guys ever gotten like a, if especially if you have a very long last name or something, you ever gotten like a letter where you're like your name's cut off? You're like, what's with that? What happened? It's just an old database, probably. Right? We don't see that so much anymore, but that is true. Um, some other real important ones in here, and you notice that I would call these the two primary character formats, but notice that there are others. And yes, people do use them. People that are very particular about their databases get into the details here. But otherwise, we usually go right to numbers. And I'm not going to the top of the list, by the way. I'm going to go first to int or integer. And there's two different forms of it. So, and I'm going to explain why. There's some database systems that just use int, like most programming languages do, and then other ones use integer, and then eventually the SQL languages like fine, both are good. So if you want to say int or the full word, that's fine. Notice that when you say int, it allows you, and this is I think this is really kind of bizarre. It allows you to go from negative whatever that is to positive whatever that is. And I suppose I could figure it out. That's hundreds, thousands, millions, 2 point whatever million, right? Or is that trillion, whatever. Or if you don't have negative numbers involved, you can go from 0 up to 4.2 of whatever that is. Right. So what this is telling you is this can hold very, very large numbers. Now, we are in this era once again where we don't think so much about memory and storage. We're like, whatever. It's a hard drive. We'll fill it, whatever. It doesn't matter. It's memory. Who cares if we overburden it? Because the truth is, these days we have very large storage in our computers, even our phones. We have lots of RAM. The computers are quick, and we don't think about these things. But in the old days, if I knew that a numeric field would only hold like a 2-digit number, I would no way in hell use this as a data type because it would be super inefficient. I would go to small int, right? And that you can see there's small, medium, big int, right? You can have these ridiculous numbers. But if I know I'm dealing with a 2 or 3 digit number, why on earth would I use a huge data type? Because here's what happens in memory. Even though I just dropped 2 numbers in, it's still using the space that this number would occupy, which is much larger, right? You do that a few million times in the database, and you have a database that becomes very inefficient, by the way, right? So if I was dealing with a really large database with really important information that I wanted to run really, really well and super fast, I would be very particular about my data types. Generally speaking, though, most modern database systems, we don't really bother to think about it because we have so much technology power now. That's like, it just took like 1/10 of a second longer. Not a big deal, right? But in massive database systems, it does become an issue. Some other important numeric formats that we'll use, by the way, so we see the floats, the doubles, and the decimals. And I think we do a little bit of decimal work here maybe in this unit, which is why I'm pointing these out. So this allows us to use, and you'll see why this one's pretty useful, an exact fixed point number. So in other words, how many decimal points after the decimal point, or how many places do we have after the decimal point? Now think about the most common scenario, money, right? So we're dealing with US dollars. How many decimal points after or how many places after decimal point? 2. So, whatever your capacity is, and then how many decimal places. Notice 2 different versions of that also, right? So commonly used for either, more precise content or money is very commonly switched to decimal format. There are other data types, and I do want to reiterate, we're going to cover this stuff more deeply later on in the course, but you need a little bit of a preview when you're building tables. Another one is date, right? So we kind of played with that a little bit in our code today, and I did mention that it goes year, month, day backwards, right? So you can have a date column. You can also have a date time, and this is kind of an interesting one because that not only includes the year, month, day, right? It also includes time. So for example, it's like, all right, sale ends at 5 p.m. Tuesday. My time says 5:01. Okay, sorry, sale was done. You missed it. That type of thing. So, and so just the date and the time, right? There's also a timestamp, and this one's kind of an interesting one. We'll once again get into this again later. But if let's say you're running some sort of transaction processing system, somebody walks into your store, they come through your point of sale, your checkout, they scan a product, goes through your computer, they pay with their credit card or whatever, and it's all processed, and then spits out a receipt electronically on paper, whatever, and you look at it. What does the receipt say on it? When did the transaction take place? What time did we get your money? Right? And that's a timestamp, right? And it is possible to kind of automate that. So in other words, when you, like, let's say somebody purchases something in your store and it gets added to your database as an order sold or whatever, you can automate that. It puts a timestamp in when it happens, right? So we can capture that data. All right. Those are the primary ones I really want to hit on here. Now we're going to move on to the ones that we're really here to learn today, which are insert, update, and delete. So I'm going to go way up to the top here at W3 Schools and take a look at the insert statement. Let me just quickly ask, anybody have any questions? You guys are all good? I see they've got something in the chat.
That was
Yeah,
and
and Finley,
that you pointed out the fact that legacy systems have these things, because what company is going to pay to update something that still works?
well, usually for security reasons is why. But you're right. When you have in database systems, typically are highly isolated and protected from other IT systems. Like, applications may have access or servers may have access. Most normal human beings can't go like get on their web browser or their phone and access a database directly. It's just not the thing that happens. So they tend to be a little more isolated. So out of all the systems that stay in legacy operation mode, databases are one of the biggest ones that stay working that way. And I think that's pretty fascinating. Some of our biggest financial systems in this country, government systems, and big like retail and business systems are built on top of very old database systems that are still operational. And they don't take them down for exactly the point that Finley just pointed out, because they work. Why? A really great example, I don't know how many of you shop at like Costco, right? Next time you go to Costco, talk to like a service rep or something, and then go look at their screen while they're talking to you, looking up a product, and you go, wow, that looks like straight out of like 1980, that screen you're looking at, because that's about right. It's like probably coded about that long ago. But they use really antiquated back-end systems, but they drive this giant corporation from it. They're not changing, why? Because the database works. It works great. And in fact, people want to know how to work it. If you ever go to Costco and talk to one of their sales reps, and one thing my wife and I have been doing, it's like we go look for like organic eggs, and they're always out, it seems. And then so we walk up to the service desk and like, which store has them, and they can tell you, which try that at like a Walmart. That's like It's not that it's not possible, but it's not happening as readily. All right, let's go back to talking about this next statement here, the insert into. Um, and basically, this is one of the key commands that we use when we have a table and we have the rights to put information into that table rather than just extract it. So the general format for that is we say insert into, declare the table name. Now notice the parentheses here, and then we list the columns in order of how we want the data to go in. So maybe it's first name, last name, phone number, something like that. Then we say values, once again, inside parentheses, and then in the same order. So if this was last name, here we're adding the last name. If this was first name, here's the first name. If this is phone number, here's the phone number. And in the format that it's expected to be received in. So for example, if it's text, it has quotations around it. If it's a number, it's an integer, it's a counting number. If it's a decimal, it's 11.4. If it's a date time, now we already got a little preview of that. That goes inside of quotes too, but year, month, day, or year, month, day timestamp. One of those formats. And the timestamps, by the way, are 24-hour timestamps. All right. So that's the general format of it. You also, if you plan on hitting all the columns in a table, instead of select columns in a table, you can just say the table name and then provide all the values. But the number of values that you're providing must match the number of columns. With this approach, I'm only inserting information into the columns that I want to insert stuff into. Now, typically, our mind would tell us, well, if there's all these columns, we should fill out every column. All right, here's an example. Have you ever seen like a form or like online or something like that where it says address to? Well, some people have to put in apartment or suite number, and normal homeowners and stuff don't. Right? Street address is good. Right? If you're in a business, and might even say like building, mail stop, suite number. And so you don't have to put information into every column necessarily. So keep that in mind. They have a couple of examples here, right? And notice they have a little customer table, ID, name, address, city, state, etc. And here they have a little example where they're inserting into that customer table which columns are being inserted, right? So customer name, address, city, state, etc. And then notice how the information is being added. Text is going inside of quotes. Okay, and I'm going to say this, right? Because I always get the question, does it have to be in single quotes? No, it could be double quotes. That's fine too. A lot of database people, and this is, I think, a little bit of legacy stuff too. We tended to use single quotes more in the old days for database stuff for whatever reason. And I think part of that might be like cross pollution with programming languages. I'm not really sure, but you can use single or double quotes, just be consistent. Now, as you look at all these pieces of information, how do we know what data type they are? We don't know from here because we don't see the data types declared, but here we know right away character for sure. These are all characters, aren't they? Why would they put the postal code as a character? I think for the reasons I explained before. Some countries use numbers, some use letters, some use both, some don't care, right? So that's a field that could be empty too. Not all countries use postal codes. Okay. So once you run the insert command, all the values here match up with the field. So Tom B. Erickson comes up here. Skagen 21 is the address. Stavanger is the city, etc. Right? And these are directly correlated. Now, if you have 5 pieces of information and 6 pieces or 6 columns and 5 pieces of information, will it work? It will, but it'll insert into the first 5. So you got to be really careful how you structure these. The general rule of thumb is if you're listing the column, you should be sending in information. There's going to be reasons though. Like, what if I did live in a country that was so small we didn't have postal codes? Everybody knows everybody. I live in Belize. No, there probably is postal codes in Belize, but I'm sure there's some like small island nation somewhere that doesn't have a postal code. So be mindful of that information. But the information is now added to the table in the right columns. All right. The next, and you know what? Let's talk quickly about null values. I think we've talked about this before. A null field is a field with no value. So if you are inserting stuff, right, and it doesn't, there's no value going in, that's what you're going to see in the database is that little null indicator. That is different than a space, which is a seemingly nothing. A space is something. Null is the absence of it. I know we talked about that. Let's go to update. So with the update statement, the way that this one works is that instead of adding a new record to a table, we're going to take a entry in a table and change part of it or all of it, right? The general form of this is, okay, which table are we updating, right? And then we go through and we say set column 1 to equal this, set column 2 to equal this. If it's a number, no quotes. If it's words, quotes. So for example, if I have, let's say I have a customer with a certain ID that needs to update their phone number, right? I can just say, update this table, set the phone number column to equal, the new phone number, where the condition would probably be that the customer ID equals whatever, So we're finding that particular customer, we're changing just their phone number. You could change just one piece of information, or you could change all the pieces of information. Okay, so that's how we do update. So they give an example here once again of this table. They have a little query preset, so they're using that customer table. They're going to change the contact name to Alfred Schmidt and the city to Frankfurt, where the customer ID equals 1, right? So you notice that Alfred changed their name to Schmidt, and then wants to change their city to Frankfurt. And then after you do the update, right, because that's user ID 1, those changes are reflected inside of here. Right, so that's basically how that works. It is possible, and this is where the safe mode thing is going to come in, and just by the way, where you can also ultimately update multiple records at the same time. And this is where it gets kind of weird, right? And I caution you to do this kind of stuff, especially in production databases. If I take all the people who are in my customers table and take their postal code and set it to all zeros if they live in the country of Mexico. Now, I don't know for a fact if Mexico has postal codes or not, or how they structure them. I can't remember the last time. I guess I sent a package or a letter down there. Anyhow, regardless, if I ran this query, if people did have, and I guess we can look up here, apparently they do have a postal code, right? If they do have a postal code in there, this would wipe it. Now, here's a problem. There could be a whole bunch of people with Mexico as their country. Do you really want to change everybody's zip code to all zeros? Probably not. I'm just saying this. Probably not. It's probably not a smart thing. So you can imagine like some of these commands, if you are not careful, and this is what safe mode is about, by the way, that you can really do some damage in the database. And this also explains why when you're working in some database systems, they don't give out admin permissions to everybody. And that's for a really good reason, especially, so people don't ruin things. Here's another example, and this is even probably the scarier one, where I could take everybody in the database in this case. So I'm not even narrowing it down to Mexico. The whole database is going to zeros on this one. Is that what you want to do? Yeah, it's a pretty easy no, right? Yeah, but they read it. Yeah, unfortunately, it is absolutely possible. All right. Next thing we're going to look at here is the delete statement. Once we get done with this one, we are going to take our break, by the way. The delete statement's another one of those that's pretty powerful, but there are times where you are working with a database system and you have a record in the database, and maybe a product database would be a really good example. So your company manufactures this product, and you manufacture it for a while, you keep it in inventory for a while, you sell out eventually, you don't rebuild it, and you know what, does it need to be in your database anymore? You know, or that might be one example. Or maybe you write scripts to keep your database efficient so that after 5 years you delete all the old orders. Why waste the space storing them? You still need them. There's probably a longer period to keep them, but I'm just using that as an example. So the syntax for this is kind of similar to the others, right? We'll say delete from, pick the table, and then set a condition, right? Notice the little warning, right? It says be careful when deleting records in a table. Notice the where clause in the delete statement. The where clause specifies which records should be deleted. If you omit the where clause, all records in the table will be deleted. Probably not what you want. And once again, safe mode is there to kind of save us, but there are times you do have to turn that off. So sometimes you do want to do that. It's like, okay, this is last year's products. Now we have this year's products, so maybe you do want to delete them. I really don't know. I would think that you would just make them inactive or something, but different scenario. All right. So once again, customer database, international entries here. So the command that they're demonstrating is delete from the customers table where the customer name equals Alfred's, right? That's the same guy we were looking at last time. So you run this command, it finds the customer name, it matches, right? That's it equals that exactly. And when you look at the output of this, you notice that it's not just deleting the name. It is deleting the entire record. Also, please remember, once deleted, there's no control Z, there's no undo, there's no undelete, there's no trash can to pull it back out of, no recycle bin or whatever, right? It's just gone. Same thing is true when you either insert a record or update a record. The change can't be undone. Whatever you did can't be undone. All you can do is take actions to try to fix it at that point. I don't really want to do these, but I do want to show you, right, that it's possible to delete all the records in a table without deleting the table. There might be times you want to do that. I don't know. Maybe like real speculatively here, maybe you run a baseball league and you keep the stats for every player for every year. Maybe you just have a table called current year, and then you keep your records there, and every year you blow it away. I don't know. I'm just throwing like ideas out there. All right, but be careful of those grand sweeping commands because you can do that. Now, keep in mind, deleting the data from a table doesn't delete the table. The table is still there. That's the other part that's important. All right. In order to try some of this stuff out, we're going to come back and work on our exercises. We are going to do about a 5-minute break here. It's about 6:47. Let's call it 6:48 and come back at 6:53. So I'll see you guys in about 5 minutes.